Yeah. So let us first understand that what happens when when you press the power button of your phone. What actually happens? So basically, the boot ROM code in your phone starts executing, and which is hardwired in the ROM. And then what happens is basically it loads the bootloader code. The bootloader code basically then loads your kernel, which then loads the first process, which is the init process, and then the other system processes are started, and then the shell loads, and then the various system applications load, and then your phone is ready to use. So behind the scenes, what happens is the bootloader basically loads the kernel. It passes various configuration parameters to load the kernel. So it could load the kernel in a safe mode, or it could load the kernel in the default mode. Now, when the kernel loads, the first process that starts. By the way, the Android OS is built on the Linux 2.6 OS, and there have been many patches added to it, to suit it for a low power embedded device like the devices that we have now. So essentially, the first process is the init process. Now, basically, uh, there's always been a question that how does an Android app execute in the device ecosystem? So what happens is basically, when the init process of the kernel starts, it basically loads a process called zygote. So that zygote, when it loads, it prepares a Dalvik instance, and whenever there is a binder or an event for an app to load, it basically forks an image of itself and then executes the app in that particular in that forked process where there is a Dalvik instance and shared memories to run the Android app. So now the question would be, what is Dalvik, what is Zygote? So Zygote, we can think of Zygote as the master process, which keeps track of any kind of events that come up. So let's say when you open your launcher and you click on any app icon, so it basically it triggers an event to Zygote to fork a process with its Dalvik instance, and then to execute that Android app's executable. So as we know that Android applications are written in Java. So what happens is the Java code that you write, that gets compiled into DEX, and then these DEX resources, layout, and everything, they get zipped, and they get zip aligned, and they get compressed into an APK file. So that APK file is downloaded, from the Play Store, and that from APK file, the DEX file is executed by Dalvik. So Dalvik is basically an optimized JVM which has been designed by Google, to execute this DEX code, which is the executable code for Android essentially. So yeah, so that would be a basic of what Android OS is. So essentially, it's a Linux system, and how apps are executed in this Linux system. Now, the most interesting thing I think would be that every app is basically a user in this Linux system. So basically, when you think about user, let's say you have a Linux server, and I make 5 users in that Linux server, and I create 5 folders, and I give permissions for those 5 folders to 5 respective users. So in this particular scenario, each user, whenever tries to remotely access that Linux server, they'll only have access to their particular folders. They cannot access to any other folder if at all they don't have a super user access or an admin access, right? So the Android ecosystem is, I think, is the same way. So what happens is the applications are sandboxed. So in the sense that every app, executes in its own sandbox, and it has its own private directory. So it's like every application runs with its own UID, and other applications cannot access the private directory of like one application cannot access the private directory of some other application until and unless that application has super user access. So let's say if you root your phone and one particular application gets super user access on your phone, then it will be able to access all the private directories of other applications. So there is one application called Titanium File Backup on Play Store, which basically takes backup of all the applications. So I think that is about the entire architecture and ecosystem. So in this particular case, what Android has tried to do is it since it sandboxes the applications, and every app is like a user on a device. So there is a basic security check that is in place. Uh, then Android has this security permissions model that it has designed. So let's say when so basically when you develop an Android application, there is an Android manifest.xml file, right? So what is this Android manifest.xml file? It is basically an object mapper of the entire Android application. So whatever components you use in the Android application. So let's say you're using an activity or a service or a receiver or a provider. So you have to define all these in the Android manifest.xml. And now if you want to safeguard, or if you want to if there are certain components which you want to be only accessed not from outside and only from inside the application, then there is a tag called the permission tag, which you can use you can define your own permissions, which could be normal, dangerous, signature or system, and use those permissions and use those permission strings for different use in the Android manifest.xml. And so basically, what are the as a developer, so let's understand it in this way, that fundamentally what would be an Android app. So it is just a client application, right, which on receiving user input, it would interact with a remote server or a cloud-based server via API. So it would make network calls, and as it executes in the device, it would have a certain memory footprint in the local file system of the device. So let's say it would create certain as the system executes the app, the certain system files would be created for diagnostic purposes, and the app would also create certain files for caching purposes. So let's say it would want to store some local data, and that data happens to be relational. It would store it in a SQLite DB. Let's say there's some data that needs to be cached, for example, access tokens, or some data that needs fast access. So it should be stored in a key value kind of a pair. It is basically flat data. So it can be stored in the shared preferences.xml file. Or let's say you want to store some kind of NoSQL data, so you can use the mobile CouchDB. So now, so what I was saying is essentially what is an Android application. So it's basically a client app in the device, running in the device, and so there are two things that it can do. It can take user input. It can so a user would use the Android application, and it would communicate to a remote server or a cloud-based server via API calls, and as the app executes in the device, it would like create a memory footprint. So it would create files for caching purposes and for diagnostics, as I mentioned. So it would be like SQLite DB or shared preferences.xml. So now when I think of a product and I want to design an Android application, so where are the places that I would try to have some basic security checks? What are the things that I would do so that people are so most of the hacks that take place are mainly on the server side, right? But how do you think people get to the servers? How do you think people get to see the data breaches, or get the data leaks? So essentially, what would a penetration tester, what would a hacker do? You know, if he or she gets hold of your APK file, the first thing that they would do is they would reverse engineer your APK file and try to read through the Smalley code, or they would try to convert the text to jar, and then use a decompiler to look at the Java code. The second thing that they would do is they would execute. So as I was mentioning that now let's say I have to design an Android app for a particular product, or a particular service, and no, I'm sorry. So I was talking about how a hacker would try to jeopardize your Android app. So he would try to read the Smalley code, or the the uh, convert from dex to jar, and then decompile the jar into Java, and try to read through the Java code and understand probably if you've used some checksums, or the way that you save your authentication tokens and stuff like that. The next thing he would do is probably execute the Android application in a rooted device, and as he uses the Android application, probably attach a HTTP proxy server, or let's say he could use Wireshark or MITM proxy, and try to see what kind of API calls that app is making. So even if you're using HTTPS, he can just pass a false certificate just to complete the client to server TCP connection, and SSL handshake, and try to read all the API calls in between. So the request response bodies. The third thing that he would do is he would try to do a ADB pull. So as you know that in Android, the private directory is /data/data and the application's package name. So there you will find folders like cache, library, documents. So if I do a ADB pull, and if I pull all the files from that particular path. So for let's consider the case of Flipkart. So Flipkart's package name is, let's say, com.flipkart.android. So its private directory would be /data/data/com.flipkart.android. So now let's say if I do a ADB pull /data/data/com.flipkart.android, so I will get all the files over there. Now I would try to see if some credit card information is being saved. I would try to check the data that I've got from pulling the files from the local file system. I'll check that with the kind of traffic that I'm capturing in between, try to make sense of it, try to see the source code as well, and try to reverse engineer and build up, understand the context of the entire Android app. And next, what I would try to do is I would try to hijack a session. So let's say I would try to see if serial user IDs are being used, or for access token MD5 is being used. Try to beat the MD5, try to do hash collisions. If a serial user ID is being used, try to increase the numbers and try to see if I can go to some other user's session. So these are the kind of things that generally a penetration tester or a hacker would do to security test, or let's say hack Android application. So now when you have these things in mind, so that what are the basic checkpoints that should be there when developing the Android application? So I think the first and the most important checkpoint would be that when the app is communicating with a remote server, so the client server communication should be secure. uh, the next checkpoint would be the client to device communication. So let's say when the app is leaving a memory footprint. So when you're saving files, when you're reading from files, when you're basically accessing files from the device, the content on the files should be encrypted because it is not in your hand, and the content stays on a customer's device. The third checkpoint would be that other apps might interact with your app on a particular device. So when some other app tries to read data from your app, and you have, let's say, content providers, so the way you save your data in the SQLite DB, try to cryptographically, try to encrypt it and save it. That would be another checkpoint, I think. And the final checkpoint would be that the executable should, like, people should not be able to reverse engineer the executable. Now, should not be able to reverse engineer is a very strong word, because obviously nothing, you cannot 100% secure an application. You can just make it harder for a person to, reverse engineer. So let's say you would have to check whether, the code is properly obfuscated, whether if possible, you can even use a paid subscription of DexGuard or DexGuard for enterprises, which I think is the best in the market for obfuscation and stopping people from reverse engineer applications. So yeah, so as I had mentioned that the future of mobile is the future of online. So it is how people access online content now. So yeah, I think this is one of the main reasons that these days companies are more focused about mobile application security, mobile device security, mobile ecosystem security, because more and more people are moving to the mobile and usage of mobile applications. This is the stack of Android. So as I had mentioned, that it's basically, the Linux kernel. It started with the Linux 2.6 kernel, and then various patches have been added to it. So one of the main patches is the application sandbox patch, and then the binder patch, and various other patches, for low power embedded devices. Then you have the hardware abstraction layer. So and then you have the Android runtime and native libraries. So Android runtime is basically Google's version of the JVM to execute the DEX files. So previously it was known as Dalvik, and now they've changed it to uh, something called Android Runtime, which basically supports just-in-time compilation. So above that is the Android framework, which is written in Java. So app developers use this particular framework, to develop third-party applications which run on this Android OS. So that is the entire stack of the Android OS and the applications that run on it. These are some basic jargons that I think we should know before proceeding. So Dex is one of the most remarkable features of Dalvik VMES. It does not use the Java bytecode; it's a homegrown format. Android programs are compiled into .dex, which are then in turn zipped into a single APK file on the device. I think I've mentioned these things, but let's just go through these things once. Android manifest.xml is a file in the Android platform that allows you to describe the functionality and the requirements of your application in Android. Yeah, so now I have basically divided into three segments. So the first segment is something called data on device. So we'll discuss on this. Second segment would be apps in device, and the third segment would be app to cloud. So what we'll try to do is, and fourth segment is deployment. So what we'll try to do is we'll try to see in detail what happens, and we'll try to understand a best practice with respect to each segment. So I think, as I have mentioned, that data on device would be the kind of data that the Android application leaves behind on the device. So basically the kind of files that the Android application accesses from its private directory or the external storage directory in the device. So it could utilize the shared preferences library from the native framework to save data in XML files. So shared preferences basically saves data in an XML file. SQLite would be to store data in like SQLite DB in the form of tables in the in the file system. Normal file storage would be just to save data in any file format in the private directory or the external directory. Like you might have seen chat applications saving their chat in DB files in the external storage directory, or images as JPGs in their external storage directory. Like WhatsApp does keep a backup of its chats as db.crypt8 in the external storage directory, and also maintains a cache of the images in the external storage directory. So yeah. So now, if this slide is, I'll just. So now let's take an example of the normal shared preferences and the normal way that developers store the data, and what we think should be the best practice to save the data. So let's look at this piece of code. I'll just zoom it for you guys. Yeah. So I think let's see this particular piece of code. It's very interesting. If you notice that let's say I want to store something as key value pair in my shared preferences. So I would just do a shared preferences. I would initialize an object of shared preferences. I would take the application context. I would do a get shared preferences. So a file name called mypref, and I would make it a mode private, and then I would use an editor to edit and then commit all the data that I want to save in that my preferences file. So let's say I want to enter a boolean value, key name 1, integer value key name 2, float value key name 3, long value key name 4, and string value key name 5. So when I do this kind of thing, when I use this shared preferences by Android, so how does the data look? How is it stored? Yeah. So now, if you can go and check this out, you can take this piece of code and try it out. You will see that the my preference.xml kind of looks like this. Like this is how Android shared preferences stores your data. So as you can see, string name key underscore name 5, the value is string value. Float name key underscore name 3, the value is 1.2. int name is equal to key underscore name 2, and the value is 1, and so on. So now let's say, now let's take a situation that now obviously the question that comes to your mind is, so how is this bad, or how can a person jeopardize the kind of the way I am storing data. So now let's say you have an app which you use to let's say recharge your wallet, or probably any kind of transactional app that would require you to use your bank account details or card details, and for obviously for better user experience purposes, companies would want that you save your cards, and so that the next time you indulge in a transaction, it is as seamless and smooth as possible. So now when the app saves your card details, so it would try to save those card details in the local file system in some file format or in some way in the private directory. So imagine it saves your card details in in plain text, and there is another app. So now what happens is, now let's say the person roots his device. Okay, so person has rooted his device, and he uses a transactional app which stores his credit card details or debit card details in plain text. So any other malicious app on the device can actually spoof on that particular data, and utilize it in whichever way he or she might want it to. Moreover, let's say you know a hacker can actually sit in between the network traffic, and in between it, when a transaction takes place, he can basically track the kind of network call that is being made, compare it to the kind of data that is saved in the device, because it's in plain text. So there's no harm in seeing what is being saved, and then probably try to draw an analogy as to what kind of logic has been written, to make that transaction happen. So yeah. So now, on the other hand, let's look. Yeah. Now let's look at this snippet of code. Now this is something that I think you'll find it on GitHub. It's an open source project. So it's basically a secure implementation of shared preferences. It's called secure preferences. It's open source. It's on GitHub. So it's very simple. So what happens is, you just like you initialized your shared preferences, you do a shared preferences prefs is equal to new secure preferences, and you get the application context, and you use the same shared preferences dot editor to create an editor object, and then you put whatever data you want to put. So I'll do the same thing, copy pasted the same code basically, put boolean key underscore name one true, key underscore name two one, etc., and I do editor one dot commit. So now if you notice the way the data is being saved, now let's go back. So now this is the file that saves data when you use the secure preferences. Now as you can see, everything is hashed. I'm sorry, it's not hashed, it's encrypted. So so this is the name, and this is the value associated to the name. Now it's very difficult for even if someone gets hold of this file, it's very difficult to understand which one is key name 5, which one is key name 3, which one is key name 2, which one is key name 4. And if you notice, what happens is, in secure preferences, you can pass your own key for encrypting the data in the local file system, or if you do not pass a key, it will use a default key. So the key is there in the file itself, but you will not be able to identify which one is the key. So I think this is a very basic thing that could be done. So whenever you want to save anything, in the local file system, you probably would want to encrypt it and store it. Now the question that mainly arises is that encryption is a very costly operation. So like, won't it harm the latency of my application? In this case, what we can say is that you have to understand the business aspect of your application, or business context of your application, and you have to decide that what kind of data do you want to encrypt and store. Like, if it is metadata related to your app, or metadata related to your app's cloud-based server that you want to keep in the device as a means of fingerprinting or uniquely identifying the client, that need not be encrypted. But there are, if it is private data related to your users, or any kind of financial data, then it needs to be encrypted. So that would be a basic check that you can put in place. So this is with respect to data on device. Now let's okay. So this is the shared preferences part. Now let's look at an SQLite, like an SQLite DB in the file system. So I think if you store I have used a tray preferences. So this is something called tray app preferences. So as you might know that shared preferences, basically it's for usage in a particular process. So it does not have a multi-process support. So if you like define a separate process, and both the processes will interact based on one shared preferences.xml file. So shared preferences still does not have that concurrent support. So there's something called tray app preferences, which internally uses the SQLite DB for this multi-process support. So when I use this tray app preferences DB, so this is how it will save file the data in your DB file. So it's just one table which has attributes like ID, key, value, module, created, updated, and migrated key. So now I think it goes similarly for the SQLite DB as well, that you have to identify. So just like when designing the schema for any kind of a product or a service, you first tend to identify the assets of your product or service, whether the assets related are relational. If they are of the relational type, you would want to go for a relational database management system. Then you think whether to go for Oracle or MySQL. uh, Similarly, in terms of security, you have to understand the business aspect and determine that what kind of data I would want to encrypt and keep. So similarly, for the case of shared preferences.xml, similarly in SQLite, when you're saving something, you can actually decide that what kind of, so probably data in a column needs to be encrypted, or probably all the columns need to be encrypted. So you have to take those decisions and then decide whether like the security. So encryption always comes with a trade-off. So if there is something, if the app needs to be very with very low latency, and the user data also needs to be encrypted, so there I think the app developers need to take a call. So the next segment is apps in device. So now what happens is, Android, as I mentioned, Android has this permission model that that app developers can very uh, effectively use to safeguard their applications. So I would like to discuss one such usage with respect to broadcast receivers. So so Android has this component called receivers. So which it's like an event listener. So whenever you have a so let's say you want to listen to some broadcast intent. So let's say you want to identify whether you want to change the usage of your app based on the kind of battery level the phone has, or let's say you want to there's a background service running for your application and you want to send a broadcast intent. And so let's say let's take this example. There's an intent service, and which is basically there to make a API call. So what happens is it will try to generate an access token on the server, and if the access token is valid, it will get that access token back. If it is invalid, it will make a call for a new access token. And when it gets the access token, it will save it in a shared preferences.xml file, and it will notify the app that I have made the API call for further actions to take place. So what it would do is it would send a broadcast across, and there is going to be a receiver written. So that receiver will receive that particular broadcast intent, and based on that it will take necessary actions. So now uh, if you just send a normal if you just send a broadcast and you send a broadcast intent, any other and every other app on the device can read that particular broadcast intent. So the best way to handle this particular situation is that you define a permission tag. So in the Android manifest.xml, you define a permission tag where you define your own permission. Make it a signature or signature system level permission. Use that permission in the manifest file itself. So probably you will do a permission Android name com dot package name or whatever, and then uses permission that particular string. And when you send the broadcast intent, you so that send broadcast function basically takes two parameters. So there is you can do a function overloading. It takes a second parameter as well. So it is the receiver permission parameter. It's a string parameter. So you can pass that permission string in that send broadcast function, and when you do so, in the manifest.xml file, where the place where you define the receiver with the receiver tag, you just pass that string as Android permission in that receiver tag as well. So that if so now what happens is only applications that have that particular permission can listen to the broadcast intents that your intent service is sending. In this particular case, if you make the permission level as normal or dangerous, then obviously other applications can listen to those broadcast intents. But if you want that broadcast intent to be only limited to your application, then what you would have to do is you would just have to make it signature system. In that case, no other application can spoof on the intent that you are sending back to the application. So I think that is a use case of how you can use the permission model of Android along with various components. So you can also use this for activities, so that activities do not become launchable independently, or activities the flow regarding the flow of the activities, or or the services that you use, or the providers. In case of providers, you can also add permissions to the providers, so that other apps that tend to query providers for data, if the app has that particular permission, then only it can query the provider for the particular data. So these kind of things. So the app to app interaction, so the permission model can be very effectively used to for the various app in-app interactions and app to app interactions inside the device. So okay, I think Bhargav has asked for an example of how we can do that. So I'll just I'm not quite sure what kind of like what do you want to do. So I'll just allow him once. So Bhargav has also raised his hand. Yeah. Hi Bhargav.
Yes,
So
how
yeah.
we can do
So
that?
I'm sorry. Could you be a bit loud?
My question is how can we achieve this thing? Yeah. How can I define a permission and just invoke the broadcast to listen to my application only?
Yeah. So as I mentioned, so what you would have to do is okay. So now you understood the use case, right? Intent service.
Understood. I need to define a custom permission in my manifest first, and my application is going to get a broadcast intent, a push notification kind of thing, and I need to just replace that string into my manifest, and whatever application having the same permission will going to listen this.
So
Uh, yeah, that's I got. But how to achieve these things? Yeah, if you can provide us any examples for this, so it will be more good to understand and implement these things.
so let's say this is your XML file, okay? This one. This box is your XML file. So yeah, so let's say this is your manifest. So since Bhargav has asked me a question, Bhargav basically wants to know that how we can do it. So I think I just mentioned it right now. So let's say this is your manifest.xml, and this is the intent service. Uh, let's say it's pretty difficult to draw over here. So this is the intent service. So now when you say, have the send broadcast function, so generally what you do is so this is the send broadcast function, and you pass the broadcast intent as a parameter, right? In this case, what you would have to do is, let's say this is your send broadcast function, you would have to pass two parameters. So the first parameter is going to be the broadcast intent, and the second parameter is going to be the permission string. So what is this permission string? So in the Android manifest.xml, you have to define a permission tag. Okay, permission tag. So when you define that permission tag, you have to use that permission tag. So you have to define a user's permission tag, and you have to use that permission string. And this string that you have defined, you have to pass this string in the send broadcast function. Okay, and the receiver tag that you have defined, in that receiver tag you have to define an Android colon permission and pass that string. When you do that, okay, so what happens is this broadcast intent that is being broadcasted from the intent service, it is bounded by that permission. So now if that permission is signature or system level permission, other apps cannot spoof on the intents that is being sent. So now, am I clear as to like what I wanted you to understand, guys? Okay, great. So Bhargav says yes. So I think that means I can move ahead. Yeah. So I'll do is I'll raise on the trends. Yeah. Oops. Right. So okay. So I think I have a code as well. So this is what generally people do. Okay. So let's say I have a button, button B is equal to button find view by ID, and I send a broadcast. So I define an intent I is equal to new intent, and I dot set action, and I broadcast this intent on the press of this button, and I have a custom receiver which checks that if the intent dot get action is this particular custom intent, then it will basically it will write a toast message. So this is the general practice that people follow. Now, what is the best practice that we want people to follow is that whenever you're sending a broadcast, see, you can send, so you do the same thing. You just pass this com.appvisual.broadcast.custom permission. So this is the permission that we have defined in our manifest file. So you pass this permission as a parameter, and in the manifest.xml file, when you define a tag for this custom receiver, you also pass this permission over there, and you also define this permission as a permission tag in your manifest.xml. So that is the best practice of how you can use the Android permission model, um, for the various Android components. So, okay. So now I think we'll go to the next segment, which is the app to cloud segment. So this is the segment where the Android application basically, interacts with a remote server or cloud-based server. So there's some basic checkpoints, and so there are three important things that I think I have highlighted over here. So always communicate over HTTPS. So I think this is the first basic security check that you should have, communicating on HTTPS, because if you're communicating on HTTP, essentially you're communicating in plain text. So any kind of a proxy server in between can sit and sniff the traffic. So when you communicate over HTTPS, you still the proxy server that is in between will still have to utilize a certificate of its own to decipher the traffic in between. So I think I'll just give a little perspective as to what happens. So when we make an API call, so what do we basically do? We establish a TCP connection, right? So the Android application is a client which does a three-way handshake, uh, and it establishes a TCP connection with the server, and then the data flows in between. So now, if you use HTTPS, what happens is there is an SSL handshake as well. So the server will send its certificate, and then from that certificate, both of them will generate their own pre-master keys, and then they will generate a symmetric key, and then using that symmetric key, this data will be encrypted, and then this data is going to be sent from the client side to the server side, right? So now when you have a proxy server in between, so since this client needs a certificate from to establish a connection, that proxy server in between has to pass a certificate, else the connection will fail. So, HTTPS is a basic, I think, necessity, because it's obviously going to encrypt the network traffic that you're sending. Now, I also mentioned the shortcoming that if I have any kind of certificate, then I can deconstruct your HTTPS traffic. So, what would be the best way to do it? So you can implement SSL pinning. So in SSL pinning, what happens is you pin a certificate in the client itself. So you keep a cert with you. So whenever the server sends you a cert, so you check the keys, you check the whether the domain name is valid, whether the date time is valid, whether the public key that is being sent is the hash of it matches with the key that you have with the cert that you have pinned in your client application, and then you can allow the SSL handshake, like, and then you can allow the exchange of data between the client and the server. So you can use SSL pinning best practices, when you're trying to establish a basically client to server connection. The third point would be gzipping the request and the response body. So now, even if I'm able to, so what I can do is I can still see the JSON request and the response bodies that are being sent with the APIs, right? So I think gzipping those request and response bodies would, make them unreadable, and it would seem as it's like it would not be humanly readable. It would not be in plain text. So I think if we see a demo, it would be much better. So I'll show you an API call traced by a proxy. So generally you would see something like this. So it's like https api.appvisual.co upload new, and you could see the JSON request body in plain text. So it's access token, app name, app digest, and now as soon as you gzip the JSON request body, you would see something like this. So it would be this is the same API call, but here the JSON request body has been gzipped. So a very simple way to do it would be you just define a byte array output stream, and you basically take the connections output stream, and you write it into this uh, so, what you do is you define a GZOS, and you pass this byte array output stream object to it, and whatever is there in your request. So this M request is basically the JSON object. So you convert it to string and pass it to this gzip output stream, and when you get this gzip output stream, you just convert it into bytes and write it to the connection object, and then make the network call. So that would be a best practice to gzipping the request body for the API call, and obviously SSL pinning and HTTPS. Now let's take the example of an SSL pinned client for Android apps. So I'll just so here what we've done is so a simple SSL test client would be, we have a key store. So we have a JKS file. So we'll try to initialize that key store. And then from that key store, we'll load the key store, and we'll basically try to make a trust manager factory. Uh, and we'll load that stored in that trust manager factory, and then we'll try to create a SSL context. Right. So when we create an SSL context, using that context we create SSL socket factory, and then from that socket factory we'll create SSL sockets, and then all the rest of the connections will be through this SSL socket. So you can keep your cert in this key store, and then you can load it and then you can write your checks in between over here. So let's say you can check whether the host name that is coming from this cert is the same with the host name that is present in your cert, whether both the dates are the same and they are valid, whether the public key that is coming matches with the public key that you have in your cert. So these are the basic checks that you can put, and then you can use the SSL socket, for further connections. So yeah, that would be a best practice of. So this is just a sample of an SSL pinned client. The next segment is the deployment segment. So yeah, this is I think one of the basic things that people should do. So before deploying on Play Store, use ProGuard to obfuscate the code to prevent reverse engineering attacks. But I would personally, so this is the way to do it on the site. It's just a screenshot from Android Studio. So I personally think that people should use DexGuard or DexGuard for enterprises, even if it is paid. But for security, I think that would not hurt because DexGuard is much more powerful than ProGuard. It also handles string obfuscation as well, which ProGuard is unable to handle. So this just makes reverse engineering tougher for people who want to reverse engineer, understand the source code of the and try to understand the business context of the application. Yeah, so I think I'm done. I have discussed all the points and all the segments that I feel best practices should be having, like an Android application should have. So now I think I'm ready for questions. Okay. So Cyber Rider has a question that so if I have a rooted device and I'm testing an app for VA, it has SSL pinning. Say if I bypass SSL pinning after analyzing the Smalley code and etc., what are the possible ways in which I can prevent SSL pinning bypass? So I think the only way that you can stop NSL, so there is something called Android Trust Killer. Yeah, you will get a recording of the webinar. Uh, there's something called Android Trust Killer, which bypasses SSL pinned clients. But so I don't know how well it would work in any of the devices. It's still pretty basic. Imagine something, the Java code that you would write, right? So that when it gets executed, if you have a JKS file from where it will load the cert and it will check with the cert that comes from the server. So if somehow you can replace, like let's say you're using a HTTP proxy server or an all protocol proxy server in between, and that proxy server has a cert which it generates. So if you can replace that cert, in the with the cert that is present in the Android application and repackage it, then probably your that Java code will load that particular cert. But then again, if you have these checks like a valid host name, uh, valid the date time, even if you change these things, but no, but I think these will come from the server itself. So yeah, if you put like really stringent checks on the SSL pinned client, I think it would be quite difficult to bypass the SSL pinning. But I would let me go back and check if there are more advanced ways of bypassing SSL pinning. But as far as I know, if you put these checks, it is very difficult. Though Android Trust Killer internally how it works, I have I don't have much idea. Probably it jumps and it adds hooks in the Dalvik VM. So for that you need a rooted device. So you might want to try Android Trust Killer once. But I'll get back to you. I'll try this and I'll get back to you. Yeah. So Priyank has asked, suppose if I have an API key or access token inside my code, how to prevent attacks on that? You should never have an API key or access token hard coded inside your code. That is like the most basic security thing that you should never have. it hard coded in your code, because your code can be reverse engineered. And especially if even if you're using ProGuard, see, ProGuard will not obfuscate your strings. So if you have something like a constants.java, and if you think of keeping the API calls and the access token as constants in that Java file, so that Java, so variable names and function names will get changed to, alphabets which can be mapped to keys using the ProGuard config file. But it will not obfuscate your string. So I think that is the reason I mentioned that people should use DexGuard or DexGuard for enterprises. So yeah, Swati has asked a question: is every APK is if every APK is using web services? If not, then it is required to perform VA over routed devices only. What needs to check in local? Swati, I think I have not been able to figure out your question. I'll just go through it once more. Uh, Okay, I think the first part of your question means that is it necessary to perform vulnerability assessment over rooted devices only? Vulnerability assessment over rooted devices only, I would say yes, because rooted devices give you a lot of access. So you can go into the private directory of the application. You can access the files in the private directory of the application. Uh, if SSL pinning has been done, then you can try to bypass SSL pinning by, try to adding hooks to the Dalvik VM, so as Android Trust Killer does, or CDS Substrate does. So in that sense, I think in rooted devices vulnerability assessment is better. uh, yeah, I think that would be it. So any more questions? Okay, any ways to, yeah, as in to avoid it. See, runtime manipulation of the app. If someone is trying to instrument your app, then it is uh, like you cannot stop them from doing it. That is, I think that would be the answer. So you have to design your application in a way that, there are less of memory leaks and data leaks, and when you're making API calls, make sure you're doing it in a secure way. When you're saving something, you're cryptographically encrypting it and saving it. So so let's say even if you do all of the things, if I let's say rebuild AOSP, right? So AOSP is the Android open source project. So let's say if I rebuild AOSP, and the Dalvik instance that Zygote launches, let's say I have added hooks to those Dalvik instances, right? So now whenever the code will execute, okay, so let's say I have written an interceptor for Dalvik, and so whenever your code will execute, it will go through that interceptor. So in that particular case, I will know exactly, so the flow of your code, right? But now if I put some basic security checks in place, I would just know the application flow, right? But I would not, I might not be able to do things that I would have done if these basic security checks are not in place. So I don't think you can stop it. Okay, Varun Jindal says that can you please go through all of the slides once quickly, a kind of summarization. Uh, okay, so we'll do a quick summary, and I think we'll end the session here. So I think I'm closing the forum for questions and security checks as in. Okay, so you can send in your questions as tweets, and we'll answer you over there, because we are currently running out of time. So I'll just summarize all the slides. So I think uh, our main focus was that why companies these days are focusing on mobile application security or mobile device security. So because the future of mobile is now the future of online, so that is how people are accessing content these days. And then we were talking about, understanding the stack of Android, so how Android has been designed, as in the Linux kernel, the hardware abstraction layer, and what is the Dalvik or Android runtime, and what is the native framework, and how third-party applications are developed and how they run on the Android OS. Then we were discussing some of the jargons that we have, like say Dex, Molly, Android manifest.xml. Then we were talking about, then I basically divided into three segments. One is data on device, one is app to app communication, and one is app to cloud communication, and the next part is deployment. So across all these segments we were talking about how what are the commonplace mistakes that take place, and what is the best practice that should be there. So in this particular case, there are numerous ways that you can save data on the device. So you can use the shared preferences, SQLite, file storage, content providers. Content providers basically use SQLite DB only. Uh, so this was an example of what not to do and what to do in terms of saving data as secured shared preferences. This was an example of how the data gets stored actually. This was an example of how SQLite DBs can be seen if you store something in plain text, and how you should encrypt it and store it, and you have to understand the business context, and then you have to decide what kind of data you want to encrypt and store. The next segment was apps and device. So we were discussing about how the Android permission model can be effectively used with various components of the Android application to leverage more security. This was the way that generally developers do, and this was one of the best practices that we discussed, in which we pass the permission string as a second parameter in the send broadcast function. Then the next segment was apps to cloud. So three important parts, that three important security checks. One is always communicate over HTTPS, implement SSL pinning and gzipping the request and the response bodies. Uh, we were seeing an API call that has been traced by a proxy without the gzipping of the request and the response body, and this is one of the best practices that we think should be followed. This is one of the best practice for an SSL pinned client for Android apps. And the last point was that before deployment, you should always obfuscate the code and prevent against reverse engineering attacks. Yeah, so that would be it to summarize the entire session. And okay, so I think we're done over here. So I would like to reintroduce myself again. My name is Shayon, and and we were discussing about Android security best practices in this mobile app security webinar. Yeah, so I think the rest of the questions that you have will be answered on Twitter, and you'll also get a recording of this webinar.